Hey, welcome back to IED. Today we're going to be discussing the design process. Well, what is design? Design is often used as a generic term that refers to anything that was made by conscious human effort. Design is also a process that is used to systematically solve problems. Well, systematically solving problems is what engineers do. Design process is a systematic problem-solving strategy. It has criteria and constraints and develops many possible solutions. It narrows down the possible solutions to one final choice. Here is a this is a rocket. There's been a lot of design process involved with that one. Okay, the design process that we use in IED. This will be the 6 steps that we use over and over and over and over and over and over again. All right, first of all, we're going to identify a problem. Second, we'll generate concepts. 3, we'll develop a solution. 4, construct and test the prototype. 5, we'll evaluate the solution. And 6, present the solution. We've kind of been doing this with every little competition we've been doing in class. I give you the problem. You guys have brainstormed to come up with ideas. You then were given time to develop a solution. Think about your coffee cup or your water bottle yesterday. What we would have done then yesterday, had we had time, is then construct your water bottle, or then with your slingshot car you had that went on the cable car that went on the fishing line, you guys constructed it. You tested it. Some of you went back to your seat and said, uh-oh, we got to redo this. And then when we were all done, you presented it. Define the problem. Validate who says it is a problem. What are the needs and wants? What are the prior solutions? Sometimes what you think is a problem may not be a problem, right? So the first step is to define the problem. Second step, generate concepts. Well, that's brainstorm possible solutions. We should be really good at this. If the technology necessary to develop the solution does not exist, scientific research may be necessary to pursue a solution. Think about your process we're going through here. Define a problem. Is the problem valid and justifiable? No? Then you better go back up and redefine your problem. Yes, we understand it. Where it's valid, we're going to try working on it. Generate concepts. Does the needed technology exist? Yes, you go to the next step. No, you're going to have to go back and define the problem. I can also tell you that if the needed technology does not exist, there's a great chance you can make a lot of money if you develop the technology. That's I'm sure that's the reason there's the problem is the technology doesn't exist. If it's a problem, that means there's a need for it. If there's a need, there's money to be had. Develop a solution. All right, this is when you guys were working on the water bottles. You guys had all those brainstorms ideas, and I said, okay, you need to come up with 6. All right. Well, what did you guys do? You guys then sketched. All right, you sketched what your solution would be. Considered the validity. You guys talked about the function. Some of you had handles on it. Aesthetics. Not too many of you really talked about what it would look like. That's what aesthetics. Safety. Lots of you had caps on it, which would be a little bit safety. Cost. I know a couple students wanted to reduce even the amount of plastic in it. Durability. They were putting rubber on it the other day, so that was making it more durable. One group said they wanted to make the plastic harder so it didn't break. Create a detailed design solution. These are annotated sketches. This is all a part of developing a solution. Annotated, annotated, annotated. What does annotated mean? Annotated means you're going to write. All right, it means you're going to write. I know that's not always a lot of fun for you guys. Construct and test a prototype. This is when you guys, for example, when we did the very first day, we built those cable cars. You guys built a testable prototype. You guys had your ideas, then you built what you were thinking about. Prototype testing, you're going to find out what was the performance. You found out how far did it go. Durability, how well did it, you could say, how well does it stay on the cable. If it's falling off the cable, it's probably not very durable because it's going to hit the ground and break. You guys tested it. You collected data. You said, hey, it went 6 inches. Some of you said it went backwards. You analyzed the data and said, we got to do something better. It's not going to win. All right? You didn't really do a test report, but you will do that here pretty soon. Evaluate the solution. You said to yourself, is it effective? All right? A couple students said, hey, ours works pretty good. Most of you with the cable car said, we got to go back and make some improvements. And some of you were looking at other people's, all right, and said, hey, that worked better. Let's try that. You probably said it quietly, as a matter of fact. And you redesigned your solution. Some people totally gave up on the previous design and started all over. Based on the evaluation of the design product, improvement or redesign may require the designer to repeat previous steps of the design process. Sometimes you end up, you made your cable car, you said, okay, the cable car, we got to make a cable car, I understand the problem. All right, is the technology there? Yep. You generated a lot of concepts, you brainstormed. You developed a solution, all right? Is it valid? You said, yep. You went and constructed it, and you said, oh, constructed it and tested it, and said, oh crap, it's not working. We got to go back to this step and make a new one. Some of you found out that you couldn't even put your car on the cable because you hadn't built it right. So you needed to go all the way back to here and generate new concepts, think about new ideas so that you could find a way to get the cable car, you could develop a way to get the cable car back on the cable or the fishing line so that you could test it again. Right? So sometimes you repeat, the loops can change. Right? The loops aren't always back one step. Sometimes they go back 2 steps. Sometimes they have to go back 3 steps. So it's not always just going backwards 1 step. Present the solution. Document the project portfolio. This will be something that we'll do as time goes on. We'll start to make some project portfolios. This will be difficult for you guys, but you'll have a checklist, and we'll get you used to looking at that. You'll do better as time goes on. You'll communicate the project. This is your formal presentation. This is the present part. You guys are going to do projects. You're going to work on them in groups. You're going to find the problem. You're then going to go through and you're going to generate concepts. You're going to brainstorm. You guys are going to build something or come up with an idea. You're going to sketch it. You're going to probably build something to let me know what it looks like. And then you're going to do this project portfolio. This is the presentation, all right? This is what happens after you evaluate it. This is this last step where you present the solution. All right, so this is a little bit more formal than just standing up in front of the class. This is what I was talking about earlier with the design process. Sometimes you get to 1 step and you go back 1. Sometimes you get here and you go back several steps. So again, this is just saying that there's several different ways. It's not linear. You could go from construct back to generate concepts. You could go to develop a solution. You could go from construct and test all the way back to redefine the problem. Well, hey, here's what I want you guys to answer. Take 3 or 4 minutes, answer these questions. What is design? What is a design process? What are the 6 steps of the design process used in IED? Write them down. Don't just sit there and look at it and say, I got it right here. Write them down. Hey, I'll catch you guys on the flip side.